Dear students, in this class, let us solve out some of the selected problems from your previous year's question papers. The problem is from the chapter Molecular Physics. The first problem, let us see what it is. I would like to read out the problem to you. The problem is this one. The force constant of carbon monoxide bond is 150 Newton per meter. Find the frequency of vibration of carbon monoxide molecule and spacing between the vibrational levels. The data given is mass of C12 is 12 atomic mass unit AMU, mass of oxygen 16 is 16 AMU. Now let us see the data given here. The data given, we'll write down. Data that is given is force constant K is equal to 150 Newton per meter. Then mass of carbon 12, we'll call it as M1, that is equal to 12 AMU. Mass of oxygen 16, we call it as M2, that is equal to 16 AMU. Now with this data given here, we have to recollect the appropriate formula by which we can find out the frequency of vibration and the spacing between vibrational levels. So we are going to calculate the frequency nu and the spacing between the vibrational levels delta E. These two things should be calculated. So the formula that we can use to get these values, the frequency formula nu is equal to 1 over 2 pi square root of K by mu. So many hertz. K is the force constant which is given to us. Mu is the reduced mass. Mu is equal to M1, M2 by M1 plus M2. So substitute the value of M1 and M2 and simplify, that will give us the value mu. So by substitution we will get that to be 12 into 16 divided by 12 plus 16. All this is in AMU. The conversion would be 1.6 into 10 raised to the power minus 27 kgs. So when you simplify this, the answer comes out to be 1.14 into 10 raised to the power minus 26 kg. So here we have the value of mu. Now let us substitute that in the formula. 1 by 2 into 3.14 into square root of K. K is given to us, that is 150 Newton per meter, divided by mu, the reduced mass. See here, we have calculated mu. Let us substitute that. 1.14 into 10 raised to the power minus 26. So on simplification, the value that you are getting here is 1.82 into 10 raised to the power 13 hertz. It's a frequency. So first thing we have found out. The next one is, what is that? The spacing between the vibrational levels. Vibrational levels are the energy levels, therefore the spacing between them is the energy difference, that is delta E, that is equal to h into nu. So substitute that. 6.625 into 10 raised to the power minus 34 joule second, that is h value, into nu, which you have calculated, 1.82 into 10 raised to the power 13 hertz. So we would like to express delta E in terms of electron volt. Therefore the complete thing we will divide by 1.6 into 10 raised to the power minus 19. So on simplification, this is giving us 7.53 into 10 raised to the power minus 2 eV. So that can be written as 0.0758 eV. This is the spacing between the vibrational levels. So we have found out what is new. So we have found out delta E also. The first problem we have solved. Next, let us go to the second problem. Now the second problem is the spacing between vibrational levels of carbon monoxide molecule is 0.08 electron volts. Calculate the value of force constant. Now they have given the data, that is mass of carbon and mass of oxygen. So here let us write down what is the data given. Data given is the spacing between the energy levels. Delta E is given, that is 0.08 electron volt. Next, mass of carbon M1 is given, 19.2 into 10 raised to the power minus 27 kgs. Then mass of oxygen M2 is given to be 25.6 into 10 power minus 27 kgs. Now here no need of converting to kgs, because it is not, it's directly given in kgs, not in AMU. But we have to do the conversion here. Energy, it is given in electron volt, therefore we will convert it in joules. So E is 1.6 in 10 raised to the power minus 19, that will be so many joules. Now what is the formula? For that what is the requirement for us? Calculate the force constant. So K is equal to how much? Now we know the formula, nu is equal to 1 by 2 pi into square root of K by mu. Once again we can calculate what is mu value, m1, m2, m1 plus m2. So do the substitution. When we do the substitution and simplify, we get the value there to be 1.097 into 10 power minus 26 kgs. This is mu value. Okay. Now we know delta E is equal to h into nu. Therefore, we have delta E is equal to h by 2 pi into square root of K by mu. Now we will square it and get an expression for K. So K will be equal to, now squaring, I'll write down the formula here, delta E into 2 pi, it goes there, divided by h whole square into mu. That's a formula, we get it from here. So do the substitution. So delta is 0.08 into 1.6 into 10 power minus 19 divided by h 6.625 into 10 raised to the power minus 34 into 2 into 3.14, all this in the brackets, square it into what is mu value, 1.097 into 10 power minus 26. So when we simplify this, the force constant, I have simplified, I will give you the answer. It turns out to be 0.0161 into 10 raised to the power minus 4 Newton per meter. Thus K is 161 Newton per meter. So we have found out what is the force constant. So I have selected another problem, the third one. Let's go to the third problem. In this problem, the force constant of carbon monoxide molecule is 187 Newton per meter. Find the frequency of vibration of carbon monoxide molecule and spacing between the vibrational levels. The reduced mass of carbon monoxide molecule is 1.145 10 raised to the power minus 26 kgs. So this is very much similar to the previous problems which we have solved, but here they have given the reduced mass straight up. Therefore data given, what is given, K is given 187 Newton per meter, then mu is given 1.145 to 10 power minus 26 kgs. What is required? Nu we want, delta E. Therefore write down the equation. Nu is equal to 1 by 2 pi square root of K by mu, substituted 1 by 2 into 3.14, 187, 1.145 into 10 raised to the power minus 26. So we simplify this. When we simplify, now I'll tell you the answer. Now for this, on simplification, we get 2.034 into 10 raised to the power 13 hertz. Okay. Next, this is the value of nu. Therefore delta E is equal to h nu. So that is equal to 6.625. All this is the repetition. The substitution and conversion to EV I have already explained to you. Anyway, let us substitute these values and see what is the answer we are going to get. Divided by 1.6 10 raised to the power 19. Why this division? Because we want the unit to be in EV. Okay. So delta E, when we simplify, we get this to be 0.0842 EV. So third problem is over. Now let's come to the fourth problem. I'll read that. Calculate the value of rotational constant of hydrogen fluoride molecule from the following data. What's the data given? Reduced mass is given, bond length is given, Planck's constant is given. So data given. Okay. This is problem number 4. Mu is equal to 9.583 into 10 power minus 28 kg, and bond length, that is R, is given 1.2 angstrom. So we will convert that into meters. 1.2 10 raised to the power minus 10 meters. Then Planck's constant is given 6.632 into 10 power minus 34 joule second. So what is the appropriate formula for this? What do you need here? We need rotational constant B is equal to question mark. Thus, write down the formula. B is equal to H divided by 8 pi square I into C. But what is I? The moment of inertia I is equal to mu r square. So calculate I. Mu value is 9.583 into 10 raised to the power minus 28 into 1.2 into 10 raised to the power minus 10 whole square. On simplification, we get I value to be equal to 11.496 into 10 raised to the power minus 48. The unit of I is kg meter square. You have I value. Now let's calculate B. So B is equal to, do the substitution, H 6.632 10 raised to the power minus 34 divided by 8 into 3.14 whole square into I 11.496 into 10 raised to the power minus 48 into C 3 into 10 raised to the power 8. Okay. On simplification, we get B to be equal to 2437 per meter. This is the force rotational constant. It's a rotational constant B, which we have found out. Now fourth problem we have solved. Let's go to the fifth problem. So this is also a problem on carbon monoxide molecule. Here they have given wave number difference in wave number. So straight away let us note down the data. They have given wave number delta nu bar is equal to 384 per meter, and mass of carbon, straight away they have given it in kgs. Mass of oxygen 2.66 10 raised to the power minus 26 kgs. Now what are we trying to calculate here? We need moment of inertia. So I is equal to question mark and equivalent bond length R is equal to question mark. So let's write down the formula. The formula here is delta nu bar is equal to H cross by 2 pi I into C. Okay. Therefore, I is equal to, I is needed, so I will be equal to what? H cross by 2 pi I delta nu bar. Now here H cross is equal to H by 2 pi. So substitution, do the substitution over here. We get I, substitute all that, H value 6.625 10 raised to the power minus 34 divided by, we get a 2 pi 2 into 2 4 and pi square is 3.14 whole square. I am putting this h cross here, therefore I get 2 pi multiplied by this 2 pi. So 4 pi square into C. This is C. C is 3 into 10 raised to the power 8 into delta nu. What is delta nu? Given 384. So 4 pi square C delta nu. Now simplification gives I to be equal to 1.45 into 10 raised to the power minus 46 kg meter square. Now we need the next thing to be calculated is equilibrium bond length R. So R will be equal to square root of I by mu. Now again, as usual, mu can be calculated m1 m2 by m1 plus m2. So it is given in kgs. You do the calculation. After substitution, simplification gives 1.14 into 10 raised to the power minus 26 kgs. This is value of mu. So let's substitute. I is 1.45 10 raised to the power minus 46 divided by mu 1.14 into 10 raised to the power minus 26. So when we simplify this, R comes out to be 1.126 10 raised to the power minus 10 meters. So when I write this in angstrom, I can write R to be equal to 1.12 angstrom. We have the equilibrium bond length and we also have the moment of inertia. So this problem is solved. Okay.